2-10 scientific notation. Working with exponents and powers still, we're going to bring in scientific notation. Scientific notation is a product. Remember, product means to multiply, so there's multiplication happening. The big thing with scientific notation that a lot of people get confused with is that first number has to be at least 1 but less than 10. And it's always times a power of 10. So examples here, for instance, if you had 47.3 times 10 to the fourth, this is not in scientific notation. This first number here, yes, it is at least 1, but it's not less than 10. Therefore, it's not in scientific notation. If you had maybe 47.3 times, actually I'll do 44.73 times 10 to the 9th to the fourth power. That's also not in scientific notation because it's not times 10 to some power. That's 9 to some power. So scientific notation would look something like this. Okay, first number here, at least 1, less than 10, and it's times 10 to some power. Key concept here, what you need to know about the key concept is when you multiply by a power of 10 and that power of 10 is positive, your decimal will move to the right. When you multiply by a negative power of 10, your decimal point moves to the left. Now, your exponent, your power, determines how many places you move. So if it's to the 5th power, you move it 5 places. If it's to the negative 7th power, you're going to still move it 7 places. What you'll need to do is convert from scientific notation to standard form. So they give us scientific notation here, and we need to convert this into standard form. We look at our exponent, 5 is positive. Look back at that key concept. When it's positive, your decimal point will move to the right. So we move it to the right, 5 spots. Here's our new decimal point. Fill it in with zeros. I'm going to rewrite my answer here, and I am pretty picky. You need to make sure that you put that comma into to your answer there. Example 2, 5.32 times 10 to the fourth. Again, look at the exponent 4. 4 is positive. Therefore, it's going to move to the right 4 spots. There's my new decimal. Fill it in with zeros. And let's not forget the comma as part of our answer. Example 3. Look at our exponent there, -6. A negative moves to the left. In this case, it'll move to the left 6 spots. So we move it to the left, 1, 2, 3, 4, 5, and 6. Decimal, and we fill in the rest with zeros. 3.81 times 10 to the negative fourth. Again, negative exponent. Negative exponents move to the left. In this case, it'll move to the left 4 spots. 2, 3, and 4. And we fill in with zeros. That's taking standard form and converting into, or I should say, that's taking scientific notation and putting into standard form. Next thing that you'll need to do is you'll actually need to take a number that's already in standard form and convert it to scientific notation. So we are given standard form here. What we need to do is take that standard form and convert it into scientific notation. In order to do this, well, here's where your decimal point would be. We need to get this number, negative 931,500,000. We need to get that first number between at least 1 but less than 10. So I'm going to move my decimal point 1, 2, 3, 4, 5, 6, 7, 8 spots. So I get negative 9.315. Okay, this first term here, the absolute value, is at least 1 but less than 10. Times 10. Now we need to think of the power here. Well, we moved this 8 times. Now you need to determine, is this going to be positive 8 or is it going to be negative 8? And that's what we need to determine. So let's say we think it's negative 8. Now, this right here, answer in scientific notation, if you have a negative exponent, remember back in our key concept, when it's a negative exponent, you will move the decimal point to the left. So I would take this decimal point and I would start moving it to the left 8 times. Well, look at my answer when I start moving it to the left. It does not correlate with that, meaning it is not the same answer. Therefore, this here cannot be a negative exponent. If it's not a negative exponent, it makes it a positive exponent. Now think about this. Positive 8 would move to the right 8 times. And that's going to look more like that answer up there. So it needs to be a positive 8. 35,600,000. Again, decimal point. Move it. 1, 2, 3, 4, 5, 6, 7. We get 3.56 times 10 to the 7th power. Again, when I think this is a positive 7, this would move to the right. When I move it to the right, it'll match that in standard form. So 3.56 times 10 to the 7th. Need to get this standard form into scientific notation. Move your decimal point. We move it 3 times, so we have 4.43 times 10. And again, we moved it 3 times. Now, if I put a 3 here, think about it. Positive moves to the right. When I move it to the right, I'm going in the wrong direction. Therefore, this isn't positive. Therefore, your exponent has to be negative. Next example, move your decimal point. When we move it, we get 6.53 times 10. And again, check it out. We move it 1, 2, 3, and 4. And that would be to the negative 4th power. Here, what we need to do, it says planets. The table lists the average radius at the equator for each of the planets in our solar system. Order the planets according to the radius from the largest to the smallest. Now, if we look at our list here, on this side, all of our radiuses are in scientific notation, meaning that this first number is at least 1, but less than 10. So if they're all in scientific notation, we're able to compare the powers of 10. And we know that the powers of 10 here, 10 to the 4th power, all those 10 to the 4th powers, would be bigger than 10 to the 3rd power. So what we need to do is go ahead and determine out of those powers of 10 which one is the largest. Well, here we go. This is 2.54. This is 6. 2.43. 7.14. 7.14 trumps all the other ones. So this would be first in order. Look at the next 3 that we have. Saturn would be next, which would be 2, not 3. Next in line, 2. And then our other 2 planets, we have 2.54 and 2.43. 2.54 is larger, so that would be 3rd. Neptune would be 4th. Now we've compared all of our powers there, 10 to the 4th power. Now we can jump back down to 10 to the 3rd. Do your comparison here. 10 to the 3rd, they're all 10 to the 3rd, all of them that are left. So we need to determine, is 6.38, 3.14, 2.44, and 6.05. Out of those numbers, 6.38 would be next, so Earth would be next in line, followed by Venus. Looking at our last 2, we have 3.40 and 2.44. So Mars would be next, followed by Mercury, and that's what it would look like from largest to smallest. This would conclude our lesson on scientific notation 2-10.